Hi, this video is about the latency information reported by CDC. Latency is the temporal relationship between the source and target database as maintained by replication. And latency is useful for lots of different things, and here's some examples. If I run a query against the target system, what data will it see? If latency spikes for some reason, say an end-of-month batch job, how quickly will it go back down? If the source system becomes unavailable, what data didn't make it to the target and thus won't make it to the target until the source becomes available again? Or, just as a general measure of replication health, if there's network bottlenecks or resource issues on the source or target systems or any other numbers of environmental issues, that can reduce the throughput that replication is able to maintain, and that can cause an increase of latency. So latency is a good measure of the overall health of your replication environment. With all those different uses, there's different pieces of information that might be important depending what question you're trying to answer. Here's again some examples. What's the average delay between when a transaction commits on the source and when it commits on the target? Or what's the oldest source transaction that hasn't made it to the target yet? Or what's the average delay between when an operation was performed on the source and when it's performed on the target? This is usually not interesting, but if you're doing dirty reads on your source and target database, this might be an interesting piece of information for you. Or what's the velocity of replication? And velocity is really only something you can measure when replication's behind. Let's say you've stopped replication for an hour, you start it up again, it's catching up. That's when you can measure velocity. And it's really how, in each second of time, how many seconds of source data can it apply? I quite like this one, and maybe especially because of its units. If you shorten that down, the units for this measurement is seconds per second. Any number of other pieces of information. These are just some of the examples that we know, that we've thought of, that we think might be interesting. But as you may know, if you're a CDC user, we provide a single value. And so I wanted to give you some background on what that value is and why we've made that choice. And we've worked with our thousands of customers over the last couple of decades to really optimize, if we're going to provide a single value, what should that value be? And we focused on the question, is replication working well? And we provide, the piece of information we provide to try to help answer that question is, when replication last committed to the target database, how old was the most recent source transaction applied to the target database? Which I know was a long sentence, so let me go into more details. Every time CDC commits to the target, it notes what was the most recent source transaction that was part of that piece of work, and calculates the difference between the current time and when that source transaction was committed on the source. So an example, if at 10:01:30 CDC commits to the target database and there was a source transaction as part of that committed at 10:01:28 a.m. on the source, and that was the most recent thing. Nothing that committed after that was part of this work, this target transaction. Then we know that at that point the latency was 2 seconds. So we would calculate a latency of 2 seconds. And when you request the latency from CDC, either specifically or it's automatically retrieved by Management Console, what you'll see is the most recently calculated value, i.e. what was the latency when CDC last committed to the target database. And this graph shows why this is a useful piece of information. And this is an example when a large transaction is processed on the source side. So there's a large source transaction, we're replicating it, we're applying it to the target. While the transaction's being applied, we won't be committing it to the target, and so we'll continue to report the low latency that existed before we began to apply that large transaction. And let's say the transaction took 10 minutes to run on the source system, and we'll imagine it takes the same 10 minutes to be applied to the target. So by the time we commit it to the target, we'll have a latency of 10 minutes. So when we finally commit to the target, latency will jump from its low value, say it's just 1 or 2 seconds, it will jump up to the 10 minutes. And then as we process the smaller OLTP load that continued on after the batch job, will likely have a good velocity. Often I've seen velocity that's easily 5 or 10. So in a single second of elapsed time on the target, we could apply 5 or 10 seconds worth of source data, so that that so that latency will quickly drop back down to its low level. And so the green line at the bottom indicates this latency value, that it'll stay low, it'll jump up when we commit, and then it'll quickly drop back down to the low level. And so for clients who are really focused on latency and may have set latency thresholds, and let's say their latency threshold was 8 minutes. So when we commit that large transaction, latency jumps up to 10 minutes. We've crossed the threshold. We'll alert our client and the customer. You'll go and look at your environment because you got the alert to see what's going on. And what you'll see by that point is that latency is already trending downwards. So you'll see, oh yes, latency did cross my threshold. It's now trending downwards. You'll be able to look at some stats if you want to see that, oh yes, there's a very, very high volume of data. There was a batch job. That's what caused the latency, but we're recovering quickly. We'll be back to the low latency environment. You'll be able to see that the systems, although latency did jump up, the system's healthy. There's no work you need to do. So that's why we chose the value we currently return. We understand, as I've talked about in this presentation, that there are a number of different questions you might be trying to answer in your environment, and different sorts of information might be useful for those different questions. So we'd really be interested in your feedback about the current value we provide, and if there is other information that would be important for you in your use case in your environment. And the best way for us to get that feedback is via our request for enhancement form. This is a standard IBM form. I've got a link here. You'll be able to find the IBM InfoSphere data replication product under the information management brand. This is a public form, so you'll be able to see the request for enhancements that our other clients have created as well, and you'll be able to search through them. You may find that there's an existing RFE that describes the use case you have, describes the latency requirements, information requirements that you have, or you may find that there isn't one that exactly matches your requirements and you might want to add your own. You can vote for others if they match yours or if you think they're interesting. So I'd really encourage you to go to this forum. We're really interested in your feedback, certainly specifically about latency, but also about anything else you're interested in sharing with us through this. So yes, thank you very much for listening.